Yeah. Number 14. Let's take a peek at it. Ooh, I think we're back here. Number 14 says use the transitive property. So it says XYZ is congruent to AOB, and AOB is congruent to WYT. So the transitive property says, I call it like the train property, the transitive property, that we have this link that joins these two statements together. That XYZ and WYT both equal this AOB. So just like with the law of syllogism, if XYZ equals AOB and WYT equals AOB, then these two things must have been equal to begin with. So we would have angle XYZ is congruent to angle WYT. We can cut out that middleman. Maybe a simpler version of this might be if I told you A equals B and B equals 5, what does A equal? 5. That's our transitive property. That if A equals B and B equals 5, then just A equals 5. Because these are linked together by this B. And as I said, the transitive property can often look like substitution. In fact, anytime you can use transitive, you can use substitution because we are basically replacing that B with that 5. But transitive is stronger in that case. Does that make sense? Sure. Okay. What other questions do we have from the homework? Ask anything. Yeah. Number 4. Number 4 says measure of angle A equals measure of angle S. Measure of angle S equals measure of angle K. And measure of angle A equals measure of angle K. They're asking for what property did I use? Well, I'm looking once again that we have this shared measure of angle S. I have these two things linking up these two statements. So angle A equals S, angle K equals S, so they must have been equal to begin with because they're both equal to the same thing. This would be the transitive property. If you put substitution, I wouldn't take any points off, but transitive is a better option here. Does that make sense why it's transitive? Do you notice how transitive shows up quite a bit? We got to be able to get that under wraps, or at least understand that we could use substitution there. Yeah. Yeah. Of congruence? Yes, that'd be good. That'd be much better. I'm not splitting hairs in this class about whether we're congruent or equal. If you use that, I could possibly give you a bonus point because you're going that step further. Other questions? Yeah. What was that? 16? So 16 says that we have the, well, I can do the given right off the bat. I noticed that one's missing. You'll notice on like our test, if I have one of these scaffold things, I'll probably have this first step missing because that can at least get you a half point. Because if I have it filled in, then you can't get that half point. So we have given. Well, if I look at the next step, it says xz plus zy equals xy. Well, let's look what's happening there. They're saying this segment xz plus this segment zy equals the entire thing. I'm adding two segments together. The only thing that sounds like adding two segments together would be our segment addition postulate. If I'm adding two segments together to make a longer segment, it is our segment addition postulate. Do not put angle addition postulate. I see it every year. I'll probably see it this year. We're talking about segments. You better talk about segments. If we're talking about segments, you should be on your segment pink sheet. If we're talking about angles, you should be on your angle sheet. But that has to do with you guys practicing this stuff and knowing what's on the individual sheets. So this is our segment addition postulate. Well, then we're going to notice we replaced xz with 3 times n plus 4. And I replaced my zy with 3n, so that's going to be our substitution property. And at this stage, now it's an algebraic proof. You just have to know how to solve this algebraically. So the first thing we realize is we need to distribute that 3. That's our distributive property. So we should have 3n plus 12 plus 3n equals 42. Like I said, that was our distributive property. Our distributive property. Then I should kind of combine like terms because my left side has this 3n and also has another 3n. Well, 3n plus 3n equals 6n plus 12 equals 42. Well, I'm combining like terms, so you could just put combine like terms, but it's easier if you just put simplify. And now I have, ooh, that doesn't look like 12, but it's 12. All right, now I have an n on that side. I need to get it by itself, and I see I have a 6 and I have a 12 there. What do I need to get rid of first, either the 6 or the 12? Yeah, I need to get rid of the 12 because we do our addition or subtraction first. So I'm going to subtract 12 from both sides. That will give me 6n equals 42 minus 12 is going to be 30. And that was our subtraction property of equality, or our subpo. And then finally, I have to divide both sides by 6. And that will be n equals 5. And that would be our division property of equality. Expect one of these on the test, okay? One of these that your only job is kind of to figure out how to write this as a statement, and then you're going to replace it with that information and solve for a variable. It's a nice hybrid between what we did and what we're learning now. Other questions? Okay, then let's move on to some more proofs. And as I said, with proof writing, you need to practice. If you're not doing the homework or if you're just copying the answer key, that's going to be problems. That means you can't do the proofs. You have to struggle through this stuff. You can't just look at it and go, I don't know how to do it. Because if you look at it for 1 second, yeah, you're not going to know how to do it. But we need to take our time, use our pink sheets, and most of these are scaffolded for us. So at least we have an idea of what they're trying to go for. We don't have that blank one. Okay, so we start off with segment proofs, and then we'll do some angle proofs, and then we'll have plenty of time to work. So, segment proof. We have E as the midpoint of DF. I need to prove that 2DE equals DF. I need 2DE equals EF. Well, let's tackle number 1 first. That's got to be our given. Yeah. You have it. Yep. I gave everyone everything. Keep flipping. So what happened was I just added DE to both sides. Maybe I change my color here. I added DE to both sides. And that would just be my addition property of equality, my ADPO. Remember, when you have scaffold stuff, you have to just realize what was added or what was changed. We need to start realizing that DE was added to both sides. And if I want to add the same thing to both sides, it's just the addition property of equality. We cannot forget about those big 4. All right. On the question we had from the homework, we had something that was like 2x plus x, and I turned it into 3x. What do we write for the reason if I have like 2x plus x equals 3x on that side? Combining like terms, or what's a better way to put that? Simplify. Simplify. So if we look here, I took DE plus DE and I turned that into 2 DEs. That is combining like terms. That's like x plus x equals 2x. I have DE plus DE equaling 2e. That is simplify. Because I combined like terms. I took DE plus DE and I turned it into 2DE. All right, our next step looks a little bit different. We now have DE plus EF equals DF. How did that happen? Think about it. Just take a peek at it. I'm going to give you a hint. It has nothing to do with what's happened so far. It's a standalone step. It says DE plus EF equals DF. It's a standalone step. I could write that at any point in that proof. It had nothing to do with the stuff in the beginning. And if you're not sure what's going on, look at the picture. Look at the picture and see how I could say DE plus EF equals DF. Delilah? It's the segment addition postulate. Because remember what the segment addition postulate says? It said you can take a segment plus another segment equaling a bigger segment. So it says DE plus EF equals DF. So if it ever looks like, man, I can't figure out how we got from one step to the other, think of it as a standalone step first. So if you thought about this as a standalone step, it might have made it a little bit easier rather than looking at how I got from 4 to 5. So this is a standalone step. That is our segment addition postulate. Our segment addition postulate. We good so far? Okay, so we're just following what they're telling us to do. So they added DE to both sides, then they turned DE plus DE equals 2DD, and then all of a sudden they used that segment addition postulate, and then all of a sudden we get to 2DE equals DF. So this must be based upon all this stuff. This can't be a standalone step. It must be based upon the steps above it. Now, if I look from here to here, that's not going to really help me. So I'm looking at 4 and 5. How did 4 and 5 make 6? What happened? What happened? You got the last one. If no one else gets it, I'll call on you, okay? Yeah.
Could it be addition?
Not addition. Delilah?
Would it be like transitive property because the for 2D was equal to DE plus EF and DE plus EF equals DF?
That is the transitive property, 100%. Good find. Notice how we have DE plus EF twice. That's important. That's what links these two statements together, that this one ended in DE plus EF and this one started in DE plus DF. These are the same things. These are the things that link those two statements together. That is our law of syllogism. That 2D equals DE plus EF, but DE plus EF equals DF. I can then say DE and DF are equal to each other by that transitive property. That is our transitive property. Good grab. We got to start seeing that transitive property. That guy's sneaky. We just have to realize that, hey, when I'm getting from a couple steps to another step, how did those two steps link up? There's usually a way that steps got linked up. Questions on that one? Okay, let's keep pushing through. Our next one says KL is congruent to LN. Here's a good idea. Mark your drawings. Because that way, if you get the proof wrong, at least I have marks on my drawing that can support what I'm supposed to do. So if it says KL is equal to LN, whoop, skip to the wrong step. I'm going to go ahead and put a tick mark on KL, and I'll put a tick mark on LN. Then it says that LM is congruent to LN. Oh, did I do the right one? KL, LN. Oh, I did the wrong thing. That would be the one. So it says KL and LN are congruent. Then it says that LN is congruent to LM. Well, doesn't that mean that everything's congruent? Yeah. So does it make sense that L is the midpoint of KM? It's in the drawing. It's in the drawing. Now I just have to defend my drawing, basically. I just have to defend my drawing. But it obviously looks like L is the midpoint. As long as you put all your tick marks on there correctly, KL, LN, tick, tick, LN, LM, might as well keep the same tick marks. So that should definitely be a midpoint. Let's prove it. So my first step is to write down my given. Okay, the really hard part about this one is the midpoint formula creates two equal segments. So I don't want a congruent symbol. So you'll notice the first step that they did is they changed the congruent symbol to an equal symbol. What allows us to change a congruent symbol to an equal symbol? It is the definition of congruence. Find that one. Find that one on your sheet and know it. That's probably one that we shouldn't have to look up every single time. We should just go, okay, equal sign, congruent symbol, or congruent symbol to an equal sign. That is definition of congruence. So go ahead and write our definition of congruence. And think about our next step. We went from KL equals LN to LM equals LN to step 3 that says KL equals LM. How did we get from 2 to 3? How do we get from 2 to 3? I have KL equals LN. No, you don't get all three of them. I bet you have it, though. Raise your hand. Sorry. I'm just seeing who thinks they know what this is. All right, Emmanuel. It is the transitive property. Like I said, we need to start realizing this. Hey, KL is equal to LN. LN is equal to LM. These two things are hooked up by LN. Like I said, I can't force you to learn this stuff. I can't force you to understand to look for this stuff. And for those of you that aren't looking at your pink sheets that are just waiting for your answers, this is going to be a terrible test for you. And I'm warning you right now, if you're not paying attention or trying to do that next step and you're just waiting for me to answer, this is going to be a terrible test for you. Happens every single year. We note that ln is the same thing, so KL and LM are linked up by that transitive property. Okay, so now I have KL equals LM. How can I say that's a midpoint then? And this is going to work the same way as if I start out with the word midpoint. Matthew? It'd be the definition of a midpoint. If I need a mathematical term, midpoint, I find it in my pink sheet, whether that means I start with the word midpoint or end with the word midpoint. If you look at the definition of midpoint, it says a midpoint has two congruent segments. So I listed those two equal segments. I have two equal segments. So I can use the definition to say, yep, those are midpoints. That's our definition of midpoint. So once again, proofs 101. If there's a fancy math word like midpoint, you need to find it in your sheets to see how to use it. Whether that means you start with midpoint or you end with the word. If you're using a mathematical word, you better have found it in your pink sheet and use that in your steps. Once again, whether that word is given to you or it's at the end of the proof, we need to use that definition. All right, our next one, we have a given. We have a congruent symbol turn into an equal symbol. What's that? Congruent to equal symbol. Definition of congruence. If we can't do that one, I don't know what we're doing in the class. That is definition of congruence. We've done it on almost every single proof. Oop. I want you to do step 3. Step 3 is a standalone step. Had nothing to do with previous 1 or 2. 3 is just a standalone step. How can I say that PQ plus QS equals PS? And how can I say TQ plus QU equals TU? They're both the same reason. Look at the picture, fill in number 3. Segment, addition, postulate. All right, then all of a sudden it has TQ plus QS equals PS. I saw some people finish this. Does anyone know what that next step is? And here's my advice for looking at that. We took basically this statement and repeated it. But did we repeat it the exact same way? No. We have basically kind of the same thing. We had that QS equals PS, but also we changed out PQ for TQ. Grayson. What allows us to change something out? Substitution. As long as those two things are equal, right? So if we look here, how do we get from here to here? Well, realistically, what we did is, do you see here where it says, if you see PQ, replace it with TQ? That's what that statement says. It says, if you see PQ, replace it with TQ. So we said, oh, I'll just take that TQ and replace that PQ with it. And I rewrite it using substitution. Okay, so if I look at step 5 kind of looks like this statement. Are they exactly the same? No, it looks like I replaced the QU with QS. Once again, I used substitution. If you look up here, it says, hey, whenever you see UQ or QU, doesn't matter, it's the same thing, you can replace it here. So UQ is the same thing as QU. Same exact thing. You can flip the letters, it's fine. So I replace QU with QS, and we have this new one. That's once again substitution. Yeah, sure. I think Yasmin had to go too. All right, we got to be able to do this next step. We've done it in every single proof. How did I get from 4 and 5 to 6? How did I get from 4 and 5 to 6? If you've been paying attention, this shouldn't be that bad. One person knows. Awesome. Chris. It is the transitive property. It is the transitive property. I now created a statement where TQ plus QS is linked to TQ plus QS. These two things are the exact same. That's what you're looking for, the transitive property, if they're the exact same. PS is equal to the same thing TU is, so we use the transitive property. And then I changed an equal sign to a congruent symbol, so that must be the definition of congruence. Once again, I'm sorry, this just takes practice. This just takes practice. I try to pick proofs that have the same steps in them. I try to have a lot that have the definition of congruence. I pick a lot that have transitive because you need to start looking for those ones. There's ones that we use all the time, and it takes you practicing them and trying to come up with what our next step is rather than me telling you what the next step is. So one more time. If you're just complacent in this class and you're just like looking at clocks and you're just waiting for me to write something down so you can copy it down, you didn't learn anything in this class. That's not how proofs work. Proofs work by you trying things, making mistakes, correcting them. All right, we'll see if we can get through most of this stuff because it's important that we get through as much as we can. All right, so this is complete the proof by giving the following missing statements the reason. Same thing we just did. Well, we should all be able to do our given. And I'm going to force some of our passive people to do something. I box something in to tell you what to do on your next step. I'm going to let you fill it in. I think you got it. I want you to fill in step 2. That way, it's just the 5 people that are participating, or 6 people. Write down what step number 2 is. If you've been paying attention, it's going to be super easy. If you haven't, it's going to be a difficult one. I boxed the important part in. This is proof 101. So it looks like all of us had, hey, if I say right angle, you find it in your pink sheet. You have to tell me what it is because there's postulate, there's theorems. So it looked like everyone put definition of right angle. And it looked like most of us were able to continue this proof. Well, if we look at the next one's a standalone thing, right? They tell us PQS, so they tell us PQS plus SQR equals PQR. That's where we have 2 angles. Put them together, they make a bigger angle. That is our angle addition postulate. Whenever you see something that looks like this, we're probably using the angle addition postulate because I have 2 angles comprised to make 1. So that's our angle addition postulate. And then my step 4. So our job is to go, okay, I went from 3 to 4. It looks like my PQR is the only thing that changed. It changed from a PQR to a 90. What allows me to replace something? Just shout it out. Substitution. I said PQR equals 90. I can replace 90 with that PQR. That is our substitution. And then we end with this word complementary. If I end with a fancy word, we go to our pink sheet, we figure out where it's in our pink sheet, and that's definition of complementary. If you haven't already, try number 2. If you haven't already, try number 2. I'm not even going to start it. You're going to start it, and you're going to do number 2. I'm going to put the other one back up for you, but we're doing number 2 right now. Let's go through this. So we have a given. We switched from a congruent sign to an equal sign. That better have been the definition of congruence. All right, then it says angle 1 and angle 2 are a linear pair. Always a good idea to have already noted what our givens were. That was actually a given. That can mess you up if you don't realize that, because otherwise you make something up and you do something wrong. That was definitely a given. So the question was, why do we sometimes list the given in 2 different places? Well, we'll list the given in 2 different places if I have 2 different things to do. So for this one, I want to convert to an equal sign. So I went ahead and did that first before I listed the second one, and then I did what I need to for the second one. Now, realize I'm not trying to trick you. If I say angle 1 and angle 2 form a linear pair, we're going to use the word linear pair. To get to the next step, I need to get linear pair to supplementary. You should have realized that was the linear pair theorem, not a definition of linear pair. This would be the linear pair theorem. So, linear pair, look it up, we use the theorem. Now my next one goes from supplementary to 180. Well, once again, if I give you a fancy math word, you look it up in your sheets. And if you look this up, you'd find out that that is the definition of Remember on your pink sheet, do you ever notice how I have those 2 little arrows that say like supplementary goes to 180? Those are to help you quickly recognize that stuff. That if I use the definition of supplementary, it goes to 180. So this is the definition of supplementary. Supplementary. I'm just going to put sup just for time-wise because I do want to get to that last one. All right, now's where you got to kind of look back at previous steps. So I went from angle 1 plus angle 2 equals 180 to also now I have angle 1 plus angle 3 equals 180. You're going to notice that that 2 got replaced with a 3. Hey, if 2 got replaced with 3, you don't need to figure out why I can do that because I told you we're doing it. Replacement means substitution. So I saw some people had transitive. I'd be okay with that, but substitution is the correct one for that one. So substitution is a much better one for that one because it does say 2 is equal to 3, so I can substitute that in. So this should be substitution. And then our last step is I need to go from 180 to supplementary. Well, if supplementary goes to 180, by using the definition of supplementary, then 180 going to supplementary will also be the definition of supplementary. If you could not do this one, that means we need to practice. And remember, practice doesn't mean a ton more problems. Guess what you can do? Just put a sheet of paper over this. Put a sheet of paper over this and see if you can do it. That's what practice is in this class. Practice isn't, I'm going to give you a ton more proofs. More proofs isn't going to help you practice. What's going to help you practice is doing the ones you've already done that you struggled on. So we cover up those answers. If we couldn't do this on our own, and maybe just tonight we just start doing that. We start practicing the ones that I struggled on. All right, our last one's a weird one, and that's why I want to do it together. If you did it, awesome job. If you got some good steps in, awesome job, because we have some kind of hidden things in here. Now, we know the first one is given. Now, what kind of messes up this one is everyone looks at this right angle, and they're like, oh, I'm going to use the definition of right angle. But can we look up the definition of right angle with me? Find definition of right angle on your pink sheet. Yeah, Savannah.
Any angle that measures 90 degrees if and only if it is a right angle.
Right. So it says right angle goes to 90 degrees. Does this say 90 degrees? No. This went from right angle to using the word complementary. So we need to find something on our pink sheet that goes from right angle to complementary. And I'm going to help you out here. I bolded a lot of important stuff on there, correct? Is there something on there? I see you guys raise your hand. I'll call on someone in just a second. I just want everyone just to take a second to look at your pink sheet. We should all be looking at our pink sheet, right? We're looking for something that goes from right angle to complementary. Are we all at least looking at our pink sheet? I need right angle to complementary. Savannah, you want to get this one too? It's not the definition of complementary. It is, yeah.
Complement theorem.
It is the complement theorem. Do you see why it's slightly different? So look at the complement theorem. Look at what I have bolded there. If you look at the complement theorem, you look at what I've bolded, does it say right angle to complementary? Yeah, that's why I wanted to help you guys out with that. This is the complement theorem. All right, then how do I go from complementary to 90? How do I go from complementary to 90? What is one that goes from complementary to 90? I don't remember if I have that one bolded in. I think I actually do. Yeah, Caroline.
Definition of complementary angle.
Is definition of complementary. That's where we use the definition. That's where we use the definition because the definition goes from complementary to 90. That's why we've got to look at our pink sheets. Don't just go, oh, I know what that means. Complementary to 90 is our definition of complementary. Oh, hang on. Is that the definition of complementary? I went too fast. That was 1 and 2. This was 1 and 2 would equal 90. I went too fast. I should have looked at what we were actually trying to do, just trying to move us through. It is not definition of complementary. Usually it would be. But does it say angle 1 plus angle 2 equals 90? No, so I didn't use the definition of complementary. It's given. It's given. I did the same thing that we'll probably always do. We'll just kind of push through. But look, that was actually our given. So we made a mistake. That would be our given. Do we see that as our given? So sometimes we have to take a pause and go, wait a minute. This went from 2 to 3. I can't do that. This would have to say measure of angle 1 plus measure of angle 2 equals 90. Okay, but our given equaled 90. I just moved one step a little too far. Now we do go from, because we're talking about angle 1 and angle 3, we are going from 90 to complementary. Now we do use the definition of complementary. And now we're going to use one that, I'll call on you in a second. Yeah. We're going to use one that I said we're only going to use in rare occasions. So it's not one that we're looking out for every single time. Now, look what happened here. I said angle 1 and angle 2 are complementary. Angle 1 and angle 3 are complementary. Do you see how they're both sharing that angle 1? I have 2 going to 1. I have 3 going to 1. It kind of looks like the transitive property. But transitive property only works with equal signs. So it's not the transitive. It's close to. I will get transitive as answers. But it's not transitive because it doesn't say angle 1 equals 2 and angle 1 equals 3. Instead, we're going to use the congruent complement theorem. And what I want you to do right now is I want you to read through that congruent complement theorem.